Hello everyone. Today we are going to learn how to extract your analog parameters from your designs. Usually when we learn about extracting parameters, we learn doing it from very simple devices such as transistors usually. And when we go into more complex structures, we try to understand how these structures are built and what are their parameters. So just to refresh everybody's memory, just open a blank paint. So if I have just any simple transistor, and there are very main two parameters that we like to categorize the transistor by is GM and R out. GM is the transconductance of that transistor. R out is the output resistance, effective output resistance, usually when the transistor is in saturation mode. These two parameters are done automatically by usually the design tools, so we don't have to worry about it. So if we have any transistor, we could just load these parameters and understand how they're being affected basically on the voltages that we apply or the current that we apply to the device. However, on a more mathematical model, we know that GM is basically the partial derivative of the current through the drain by the VGS, del ID to del VGS, when VDS is constant. So if we just write the we can write the NMOS. This is an NMOS, the terminals of the device. So to calculate the GM, we would have to take the derivative of ID. So we would have to find this ID that is going through the drain of the device, and take the derivative of via VGS when the VDS is constant, meaning this would be the mathematical model. However, let's say we have a box, and the box also could be categorized by its transconductance and its effective output resistance. We don't really know what's in the box. It's not like the transistor, so we need to measure it. We don't know how to measure it. So in this video, I'm going to show you how to extract the parameters that are similar to GM and R out from a transistor, just to do it from a box using cadence tools. And also I will teach you how to extract capacitance parameters. So in order to understand, so if the GM of the transistor is this, meaning it follows this equation, then the effective GM of the box is very similar. It's just we have to replace the terminals. It's going to be the partial derivative of I out of the box by V in. So V in would go probably like here, and we would have some reference to the ground. So this would be like similar to the source of the transistor. So it's a very similar model. It's just we don't really know what's in the box. Where here we know it's a transistor. So we're missing here that V out is constant. So it's really, these two equations are very similar. If we look at R out, so R out of the transistor would be 1 over the partial derivative of ID by, instead of VGS, it would be VDS, where VGS is constant. So we know that I over V is conductance, and 1 over that would give us the resistance. So that's the R out of the transistor. Whereas for the blocks, we want to know what's the